Hi guys. Last class I was trying to describe about motion and we come across the reference point and we know the importance of the reference point, and along that we understood about the frame of reference. So with respect to frame of reference we can say motion and rest are relative terms. Today I would like to talk about new concepts which we already know, just recall them. First is distance. So distance is nothing but the total path length covered by the object during the motion. When object is in motion, the total path length covered by the object is known as distance. So let us understand that with an example. Suppose here I am having a kilometer line, just one dimensions. So just like this is one dimensions, and here it is a starting point and origin and up to 60 kilometer, and this contains different stops or different reference points, not reference points, different locations you can take, and the arrow mark shows about the motion in the forward direction and motion in the backward direction. Now suppose if I ask a question, so that is, suppose I started from O and went up to A and came back to B. So I started from O, went up to A and I came back up to B. So the question is, what is my path length or distance I covered? So in that case we need to write O to A plus A to B, and O to A is 60 kilometers and A to B. To find the A to B, so we can subtract from OA minus OB. If we can subtract from OA minus OB, we can get the value of AB. Now here OB equal to 35. So if we can subtract OB equal to 35 and OA equal to 60. So 60 minus 35 AB gives the value of 25. So AB value is 25 kilometers. Now the total path length, total means we need to sum up. So if you sum that OA and AB, we can get the total path length. Here in this case it goes to 85 kilometers. So that we can say that total distance. Similarly, distance, we need to define one more physical quantity, that is displacement. So displacement is nothing but the shortest distance measured from the initial to final position of an object is known as the displacement. This definition is little tricky. It is also appears like distance, but it is depends upon the initial and final position of an object. The shortest distance measured from the initial to the final position of an object is known as the displacement. So let us try to understand that with an example. So before that, whenever we are dealing with the displacement, so keep it in mind, the displacement along your moving direction is taken as positive. Suppose if this is my reference line, this is at origin, I am moving along the positive x-axis. So if I am moving along positive x-axis, so my displacement here is supposed to be positive. And when I coming back, so in this direction, when we are moving back, so by the time we will take the displacement from the initial to final. So since the displacement is a direction sensitive, So we won't get any trouble while dealing the problems. So for the as a remember point, if you can take this displacement along your moving direction, so that we can take as positive. So let us take one small example. In this case, same one dimensional. So in this one, O is the origin point and A, B, C are the different locations. Now here the question is, I started from O, went up to A and came back up to B. So in the earlier case, same. So I started from O, went up to A and reached back to location B. Now in this case, I want to find what is my total displacement. So to find the total displacement, here we need to depend upon initial point and final point. So O is my initial point and B is my final point. So according to definition of displacement, the shortest distance between initial and final point. Now here the shortest distance between the initial and the final point is nothing but from this straight line, that is from O to A. So O to A is, sorry, O to B. So O to B is the displacement because that is the shortest point, shortest distance between the initial and final point. Now we need to measure that shortest point, shortest distance. So for that, if we can take the shortest distance from this number line, if we can directly locate that from the O to the point B, so this is the distance of 35 kilometer. So this is the 35 kilometers the displacement. And if you can take one more example for the displacement, suppose in the same case, but the situation is different. That is, if I started from O, went up to A, and I came back to O. So I started from O, went up to A, and came back up to same point where I started. It means where I started, there I reached. So in this case, what is my total displacement? So the total displacement in this case equal to 0. So there won't be any displacement. Why? Because so my initial point and final point, they both are same. If they both are same, the displacement is equal to 0. So this is how we define displacement. The displacement we can define as the shortest distance between initial and final point is defined as displacement. So after learning displacement, let's see about uniform motion. One more definition. Uniform motion, it's defined as if an object covers equal distances in equal intervals of time. If an object covers equal distances in equal intervals of time is known as uniform motion. So if an object, here my object is a car, the car is moving equal distances from 10 to 20 meters. It is taken time up to here 15 minutes. From again 20 to 30. Here it is a 15 minutes. Similarly 30 to 40. So again 15 minutes. So like that, if you can see, the distance interval is same and the time interval is also same. So in that case, we can say the car is moving in uniform motion. So the uniform motion we define as if an object moves or covers equal distances in equal intervals of time is known as uniform motion. So the best rememberable example for this uniform motion is the march past. When the soldiers do march past, so they will do uniformly, and they all cover equal distances in equal intervals of time. So that is the best example for the uniform motion. So finally, we can define uniform as if an object covers equal distances in equal intervals of time. So that motion, we can say the object is moving in uniform motion. Non-uniform motion. If an object covers unequal distances in equal intervals of time is known as non-uniform motion. So non-uniform, here let's take the case, the car is moving initially at 9:30 a.m. It is at 12 meters. So after 9:45 it means time interval is 15 minutes and it covered 7 meter. And in next 15 minutes it covered 4 meters, 23 minus 19, 4 meters. And next 15 minutes it covered 12 meters. So in this case the time interval is same, 15 minutes, but the distance covered by the car is different in each interval of time. So this kind of motion we known as non-uniform motions. Usually whatever we do when we walk, when a vehicle goes, or any kind of, everything will be described with the non-uniform motions. Because in reality when it comes, every times we need to apply brakes, we need to face some obstacles. So sometimes we can get freeway, so we can increase speed. Sometimes we can get traffic, we need to decrease speed. So when we are usually traveling, so obviously that motion gives an example for non-uniform motions. So if you can show the same non-uniform motion for the definition, if an object covers unequal distances in equal intervals of time, so this kind of motion is known as non-uniform motion. So motion can represented with the help of graphic. So graphical representation is very helpful to understand the motion, whether it's a uniform motion or non-uniform motion. It's easy to interpret. So we should know certain graphical knowledge. So by seeing the graph, we can able to understand what kind of motion it should be. Let us see some graphs regarding the motion. So how the shape of the graph look like and what it really means about. These are the some position versus time graphs which is given in the NCERT. So we will represent position as x and time as t. Suppose if you can see the position of an object at 40. So this is the graph is showing straight line at here. So the object is, if take the object at here, if you can take, this is an object, a car. The car is at 40 meters, and when the time is increases, the car is not moving at all. If it is not moving, So it is at the same position. Here you can see the time is increasing 10, 20, 30, 40, 50, 60. But the location of the car is constant. So the location of the car is at 40 meters only. So this graph tells about an object is at rest. Means if a graph is a plot between x versus time and a line which is parallel to x-axis. So this line represents about object is at rest. So if an object is at rest, the position time graph represents a straight line which is parallel to time axis. So whenever we draw graphs, we will draw certain graphs like position versus time and velocity versus time and acceleration versus time. So always we will take time along the x-axis. So that is one of the point. So the position is constant with respect to time. So in the graph manner, it is showing a straight line. So this tells about the object is at rest. Object is at rest. Suppose if the question is like this, plot a graph for a train which is at rest on the platform. If the train is at rest on the platform, it is not moving. So when the time increases, the position of the trains remains the same. So the graph will represent as a straight line which is equal to parallel to time axis. And one more graph at here. So this is also position versus time, x versus t. Now if you can observe the shape of the graph, now the shape of the graph is a straight line but which is passing to the horizon. Did not draw the arrow mark, but so it is. Now if you can see, when the time increases, the position also changes. Suppose here you can take the corresponding time at here, and here you can take the corresponding time at here. It means when the time increases, the position also will changes. And this graph is a straight line graph, but that straight line passing through origin. A straight line which is passing through origin. So this graph represents position time graph for uniform motion. The straight line graph represents position time graph for uniform motion. And let's see the position time graph for non-uniform motion. So the third one which is given. So this is the graph for the position and versus the time, x versus t, for a car, a moving car. So if you can closely observe the curve, the line, the plot of the graph is not a straight line, it is just like a curve. Now, initially at time t equal to 0, the position represents 0. So like that, when the time is increases, slowly the position is changing. Now this change is not a straight line, just like we discussed above. It is just like a curve. So this line we represent as non-uniform motion. So the difference between uniform motion and non-uniform motion is only this. Uniform motion should always represent a straight line graph and that should pass us through origin. But when it comes to non-uniform motion, the graph is not a straight line. It's just a curve. So this represents about the motion is non-uniform. So these are the three different varieties, three different kinds of the graphs, we will represent position versus time. So this one for object at rest, and this one for position time graph for object at motion, sorry, uniform motion, object in uniform motion. And third one, it is for non-uniform motion. So by seeing graphs, we need to understand, we need to interpret it. So that interpretation gives better knowledge. And not only that, by using these graphs, ahead we will calculate like speed, velocity, accelerations. So to calculate that, we need to understand graphs very carefully. So let us see the same graph with the help of PHET stimulation. Let me describe about this. This is the moving man PHET stimulation, and here I am having position versus time, and this axis tells about position x, and this tells about time. And here I'm having the facility that I can move this person, so he is my moving man. So it depends upon the my movement, so the graph of his motion can be plotted. So what I am drawing is a typical graph, so let me now to draw that for first. Now there is a position. Now if I keep the moving man at 0, or let me take this as, let him at 4. Now he is not moving, he is at rest, not moving, and he is at rest. When he is at rest, now if you can see the position time plot. So when the time is increases, so this is the time. So when the time is increasing, so 0, 2, 4, 6, 8 like that seconds, and the position, so where he was, there he is, the position of the person is remains constant. So if the object is at rest, since he is at 4 meters from the reference point, so this is a 0 meters as a reference point. So that's why the graph has a plot from 4. Suppose if we can change the moving man from there, and if we can replace him in some another position, let me take him at the origin. Now here you can see before he was 4, I moved him as a reference point origin. Now the graph is not any shapes, it's just a straight line. So now the location, where is the location? That is location x is at 0. So that is the location. And the time, when time equal to 2 seconds, he is at 0. When time equal to 6 seconds, he is at 0. When time equal to 10 seconds, he is also at 0. Like that, when time goes on 14 seconds, he is at 0. So it means the object is at rest. So if the object is at rest, we will represent the position and time graph with a straight line. Now let us make move object. Now I would like to move him in the uniform motion. Suppose if I move him uniform motion like this with the help of the arrow marker here. So if we can able to move him uniformly, if I can able to move him uniformly, it means I need to move the arrow mark very smoothly. That is little difficult to get the perfect line. Now I will try to move that after hitting the play button. Now here you can see he is not moving, he is at 0. Now I am trying to move him So he's moving, let it moving in the uniformly. So now he's reached up to at 10. Now he's at rest. Let's interpret the graph. So the graph tells about moving man is moving man is at O from 2 seconds to 4 seconds. So from 2 seconds to 4 seconds, he is at rest. Yeah, he do not move, he is at rest. After 4 seconds, here you can see the curve is increasing straight line. Yeah, it's not perfect straight line, but we can take this as a straight line. It means he is moving with a uniform motion. And almost all 11.5 seconds. Suppose if I take this as 11.5 seconds, here it is 12 seconds. So from 4 seconds to 11.5 seconds, he moved uniformly in the forward direction. Now after that, he reached at 10 meters. He reached up to 10 meters. Then after, you can see the line is parallel to time axis. It means he is at a rest. He is at rest. Now altogether, if I can describe his motion with a clear screen, so the graph having different portions. So from 0 to 4, so this is at rest at 0 meter. From 4 to, let me take as 11.5 seconds. From 4 seconds to 11.5 seconds, he is in uniform motion. The uniform motion moved forward. Uniform motion moved forward. Then after, from 11.5 to, let me take as in this is an 18.5 seconds. From 11.5 seconds to 18.5 seconds, he is again at rest. So the curve represents different types. So that we need to understand. So if the object is at rest, what is the shape of the curve? If object is in uniform motion, what is the shape of the curve? If object is moving in the forward, what is the shape of the curve? So those things we need to interpret from the graph. Now I would like to do one small action with this moving man. Suppose if I move him uniformly forward direction and I made him to rest, and I want to move back him to as a uniform motion backwards, and from the backwards to I want to move him again negative direction, and again it is moving in the forward direction. Now here we can understand different kinds of the motions with respect to time. Up to at here he is at rest, and up to at here uniformly moving forward, uniformly moving forward, and up to at here again he is at rest 5 meters, and up to at here uniformly moved backward. Yeah, do you notice the forward motion and the backward motion, how the graph is representing? So for the forward motion and the backward motion, if you can closely observe, so the curve is increasing upward direction, and the backward motion the curve is decreasing, so it is a falling downward direction. So these two shapes are also having a good meaning to understand. And the rest of the motion, so here from the other part of the motion, it is entirely went to as a non-uniform motion. So increases, decreases, increases, decreases. So likely for the motion of an object, especially when it comes to position versus displacement, we will plot certain graphs. From the graph information, we will understand how the object motion is.